All right, I think I'm gonna get us started. Thank you guys so much for coming to this talk. I know you guys have a lot of choices, so just wanna say hi and thank you for being here. If you don't mind, if I could take a picture of this awesome crowd. So please wave, thank you. Nice, thank you. So my name's Rita. I'm a software engineer at Microsoft. So today we're gonna talk about security and identity, and hopefully in the next 30 minutes or so, you will learn some things about how you can protect your Kubernetes data if you decide to store them in SCD, or for companies that don't want to store their secrets in SCD somewhere outside of Kubernetes. I'll also talk about some of the ways you can do that, and also how to restrict access to your cloud resources with Pod Identity. So lots of great content, lots of demos, so let's get started. So my name is Rita Zhang. I'm from San Francisco, and I am a software engineer on the Azure Kubernetes service team, focusing specifically on upstream features. So I'm also one of the maintainers for three repos, three solutions that I'm going to talk about today. And I just want to give a quick shout out to all the awesome folks that are also working with me on these three solutions. So if you want to check these out later after the talk, and if you have questions, feedback, or issues, please don't hesitate to reach out via Twitter or just GitHub. So I don't know how many of you guys remember this, but earlier this year, Tesla, among maybe other companies, were basically in the news about how their Kubernetes cluster was hacked for crypto mining. And how did they do that? So the hackers were basically able to get access to their AWS credentials because they didn't have a secure Kubernetes dashboard. And because they were storing their AWS credentials as Kubernetes secrets stored in SCD, it was quite easy for the hacker to get their hands on all of their awesome AWS resources. And that's how they use it for crypto mining. So before we talk about specific solutions, let's kind of talk about the basics. As we saw in yesterday's keynote, SCD is used as the persistent storage for Kubernetes API objects, and specifically Kubernetes secrets. So let's talk about Kubernetes secrets. Now, Kubernetes secrets is a construct that was originally created to protect the sensitive data that we have. So be it your keys, your certs, your passwords of your applications, or Kubernetes secrets to run your entire cluster, right? And the purpose of it was really to prevent developers or keep developers from basically hard coding their application secrets into their containers. Now, this was a great concept, but Kubernetes secrets is actually stored as a base64 encoded plain text, not encrypted. And a lot of people, and one of the purpose of this talk was really to bring awareness, right? Is a lot of people thought, hey, I can't read the secret, so it must be encrypted. No, it's just encoded, right? So you might say, well, what's a big deal, right? So it's not encrypted. Well, so this guy wrote this blog post, right, about what it means to run a unprotected SCD. So not sure if you guys are aware, but authentication for SCD was added back in 2.1, and it is actually off by default, right, and for backward compatibility. And this is basically also why we want to really promote everyone to please run with 3.0 plus. And again, you might say, well, what's the big deal, right? So I'm not sure how many of you guys know Shodan. Shodan is this search engine that basically allows us to look at vulnerable things or servers that are exposed on the internet, right? It's actually really useful for hackers. And so what happened was this guy did a quick search on Shodan using 2379, because that's the port SCD uses. And sure enough, the guy found 2,000 plus SCD servers wide open on the internet. And because it's so easy to use, you can just use the REST API to query all the content in the store, and sure enough, you get people's MySQL root secrets and passwords and AWS secrets, right? So do you need a server for your crypto mining? Here you go. So I got kind of curious, so I went and did the whole Shodan thing myself, and specifically looking for SCDs for Kubernetes. And sure enough, I got a bunch of IP addresses for people's SCD clusters. And again, not to name names and not to make things bad for this one cluster, but I found this is the content of a SCD that belongs to somebody's Kubernetes cluster. And as you can see, this is somebody's Docker registry, right? So I can totally just push like bad code to like their Docker registry right now. So you probably don't want that. And again, this is just to show you if an attacker somehow gets their hands on your cluster and the database, they can pretty much compromise your entire cluster, and not to mention to get access on your cloud resources. And this is actually pretty bad. Like I saw a lot of very open SCDs out there on Shodan. So you might be like, oh crap, this is really, really bad. What can I do, right? So here are some things that you can do in your organization, right, to make sure that your cluster is secure. Now, I'm not going to get into the details because there's a lot that you can do, ranging from setting up network policies, making sure your Kubernetes dashboard is secure. But I'm going to focus on the data part of Kubernetes for this talk. And specifically, make sure you restrict access to SCD, enable authentication, make sure you can only get to the APIs and the SCD CTLs if you have the certs enabled, and make sure that you have encryption enabled for your SCD, right? And so that's the first half of the talk. And then I'm going to move on and talk about, well, what if for folks, especially a lot of enterprises, if you didn't want to put all your secrets of your applications, your certs, as Kubernetes secrets. And that was quite often the case. And so we're going to talk about how you can actually get access to those content if you store outside of Kubernetes, and how you can restrict access to those data if you store them outside of Kubernetes, and how you can do that with pod identity. So again, let's cover some basics, right? So what happens when we create a Kubernetes secret? Well, when a Kubernetes secret is created, the API server basically takes the content of your secret and stores them, base64 encoded, stores them in SCD. And when you create a pod using that secret, what happens is the API server schedules the pod on an available node, and when the node is initialized, when the pod is initialized, the secret then is copied over from SCD and mounted as a volume, right? So when the volume is attached to your pod, then the data is actually exposed to your container on the file system. That is not supposed to happen. So I just talked about encryption, right? So what are some ways that we can do this? We can encrypt our data in SCD. So in 1.7, encryption at rest was introduced. Now this requires you running SCD v3, but also it allows us to create a key or to tell API server that, hey, look at this config file, and it has a key that I've specified that I want to use for encryption. But it's a step further, but it wasn't quite good enough. And the reason for that is, again, this config file sits on a master node somewhere, and it's, again, base64 encoded. So it's not quite the final solution that we wanted, because ultimately it is still on the file system and not very secure. So come 1.10, the community said, okay, let's take the best part of key management services out there that are on the market, and let's leverage that. So once again, when you create a secret, what happens is the API server then delegates the encryption process to the KMS provider that you can actually deploy in your, onto your master nodes. So the KMS provider then facilitates the process to grab the key from your KMS and use it for encryption. Now, the benefit of this is the folks that are actually doing the key management are now probably may not be the same people that are doing cluster management. So you have this separation of concerns. But also you are actually able to use industry trusted, industry grade key management system out there on the market, like Azure Key Vault, Google Cloud KMS. And a lot of companies really want hardware security module keys to be used for their encryption. So here's an example of what that looks like. Once again, here is the encryption configuration file that you would deploy onto your masters. And the API server then looks for that configuration. And this is how we tell Kubernetes, hey, I want you to basically encrypt secrets, but you can also specify other content, other Kubernetes objects that you want to encrypt, for example, config maps, right? And here's me specifying, now you can talk to the KMS plugin via this Unix socket. Now, before we go into demos, so here's the high-level design, right? So this implementation is a gRPC implementation. And what happens is the gRPC client is now embedded in Kubernetes API server. And so when the API server gets a request for encrypting or creating a secret for encryption or decryption, then the API server delegates that encryption process and calls that the out-of-tree KMS provider, which is now acting as a gRPC server. And when that gRPC server gets the request, then it does all the handshakes between that provider and the external KMS. And once the key is, once the provider gets the key, then it's used for encryption. All right, so demo time. All right, so here I have a Kubernetes cluster that I've created with the encryption, KMS encryption enabled. So as you can see here, my cluster has 3 master nodes. And what I've done is, so let's take a look at the encryption configuration, right? So like I mentioned earlier, what I've done is I basically telling Kubernetes, and go ahead and encrypt my secrets, making sure that when they're stored in STD, it's actually encrypted with the key coming from an Azure Key Vault. And in this case, my KMS provider is actually running off of that Unix socket. And what that actually looks like, so it's actually running as a container. So I'm going to go ahead and look at the container that's running, right? So I'm going to tail this really quick so that you guys can see what happens, right, when I actually create a secret. All right, so this is a very simple secret that I'm going to create. And as you saw earlier, once I do that, it basically the API server basically hands off the encryption process to the container that's running in this master node. So now you might say, well, as an end user, what is that experience? Well, the experience is actually exactly the same, right? The only difference is, as you can see, now I'm using SCDCTL to look at the actual raw content in SCD in case some dude gets access to it. And in this case, as you can see, the content is all encrypted. Even if I were to back it up and I lost a backup and I go look at the content, I wouldn't be able to look at it without the keys that are coming from Azure Key Vault. All right, so that was a brief demonstration of the KMS provider plugin. And once again, you can use this to encrypt your SCD data using a key from a KMS managed key. And what I demonstrated earlier was using a Azure Key Vault KMS plugin, but there's also one for Google KMS. Now, as I mentioned earlier, Kubernetes Secrets is great. But a lot of organizations already have a centralized location where they actually keep all their application secrets, whether that's your certificates or connection strings to your databases, but they already have a centralized location. So a lot of companies have an issue with again, recreating this information in Kubernetes and manage it inside of Kubernetes as a Kubernetes object. So then the question is, well, is it possible for me to store this information somewhere else and be able to query that data in my application? Well, yes, we're introducing Key Vault Flexvolume. Now, let's talk about what is a Flexvolume. So a Flexvolume is a Kubernetes construct that was really created to allow us to mount vendor-specific volumes into Kubernetes. And in this case, we've created a Key Vault Flexvolume such that each Key Vault Flexvolume driver gets deployed on each kubelet node. So when a kubelet is creating a pod and it sees that, hey, you want to mount a Key Vault Flexvolume, what happens is it actually looks for that driver in the file system, and then the driver then does the actual work to go grab the secrets or the keys or the certificates that you want to grab from, again, an external KMS, and mounts that information, mounts that data into your container. All right. So let's look at a demo to see how this actually works. So first, I have a Kubernetes cluster, and I just want to use a different one just to show that this works everywhere. But this is a AKS cluster. It's an Azure Kubernetes service cluster. It's a managed cluster. So I don't get to touch the masters, but for this purpose, this all works across managed Kubernetes service or your own Kubernetes cluster if you're managing it yourself. Okay, so first, let's install this Kubernetes Key Vault Flexvolume. So as I mentioned earlier, I'm actually deploying this as a daemon set across all of my nodes, my agent nodes. And the reason for that is I want to make sure I actually install the Flexvolume driver in this volume plugin that is specified to my kubelet. So I'm going to go ahead and deploy this. And once this is deployed, now the driver is running on each node, as you can see here. And next, I'm going to actually show a demo of how this is being used. So here's just an Nginx pod, and it is mounting a Flexvolume. And here I am specifying I'm using the Key Vault Flexvolume, and I want to grab a secret of type secret, and the secret name is password, right? And I want to grab the content from, this is the name of my Key Vault, and I want to be able to mount it at this mount point. So I'm going to go ahead and create this demo application, and now it is getting created. So to make sure that the content is actually mounted, I'm just going to cat it to make sure it is exposed in the container. And voila, that's the actual value of the password. Not very fancy, but it is being stored and managed on Azure Key Vault. All right, so that was a quick demonstration of the Key Vault Flexvolume driver. Now, I just demonstrated how it's used with Azure Key Vault, but we're also talking with other Key Vault KMS providers out there, and hope to add other providers into this solution. So Azure just happens to be the first one. And again, you can use this to basically continue to store your secret data in your own KMS system and be able to use them in your application. So now you might have another question. Well, is there a way for me to restrict access to my Key Vault and my cloud resources at the pod level, right? So I was able to get all that content from Key Vault, but it was using a secret that was basically shared in my namespace. But what if I want to get down to the pod level? Can I do that? And that's where pod identity comes in. So what is pod identity? Pod identity basically restricts and enables pod access to individual resources that uses Azure AD as the identity provider, right? So think of your Azure SQL Server, or even if you want to build a custom API that relies on Azure AD as your identity provider and your access control. So with pod identity, you can basically request access to those resources by using the identity that's assigned to that pod and grab the access control from Azure AD. So how does this actually work? Now, before we even talk about Kubernetes, there are folks in the organization that's probably going to create the actual identity. So the prerequisite is you have an identity already created, and you have probably a different group that's going to grant access to the resources that you want access to for that particular identity, right? Whether that's a database or Key Vault or maybe some VMs, right? So somebody needs to grant access to that identity. And once that's done, your Kubernetes cluster operator at this point deploys the pod identity solution in the cluster. And the first thing this person needs to do is create an Azure identity object in the cluster so that we can map an actual identity that is, Azure identity, map that into Azure identity object in the cluster. And the second thing we need to do is create a binding, right? So that when we deploy a pod, the pod has some labels, and if that label is mapped to a mapping, then we actually assign that identity to that pod. And once this assignment is done and the mapping association is completed, then the pod identity uses the identity that's assigned on the pod to retrieve access token from Azure AD. And once this access token is returned to the pod, then the pod can use that access token to talk to the resource it wants to access to. All right, so let's look at a demo. So first, we want to deploy the pod identity solution in the cluster. And as you can see, what we have is basically a bunch of CRD objects, types, specifically the Azure identity object and the Azure identity binding that allows us to make that association. And also some RBAC rules to make sure that this solution has access to monitor when pods are actually getting deployed. So next, we're going to go ahead and deploy this. And once this is deployed in the cluster, the components look something like this, right? And first thing, as I mentioned before, you need to create the actual identity. So this is basically mapped to an actual AD identity, the name of the identity and the client ID. And next, we need to create a binding, right? And what this does is hold on. Yeah, so now we're creating the identity. And next, we need to actually create the binding. And what this basically says is, well, if you have a pod with this label, then go ahead and assign this identity to that pod. So we're going to go ahead and create the binding. And now the binding is created. Let's look at an actual demo, right? So this demo, all it does is it lists out a list of VMs in a resource group. But in order to do that, I basically already assigned list permission for the Azure identity on the resource group. And as you can see here, this pod has this label. And what that does is the binding that looks for this label and assigns the identity that I already have in the cluster. So once this demo is created, it looks something like this. And let's look at the actual application as it runs so that we make sure that it's actually able to get the access token. So as you can see here, it's able to successfully acquire the token with assigned identity, and it's able to list a list of VMs in that particular resource group. All right, so that was pod identity, okay? So pod identity helps us restrict and enable specific pod access to specific resources that uses Azure AD as the identity provider. Now, what if we take what we just used for Flexvolume and map and mirror that with a pod identity so that we make sure only certain pod with certain identity have access to our secrets that we store in Key Vault. So now let's take a look at this demo. Again, the same Key Vault demo that I showed earlier, which tries to grab the secret from Key Vault, but here, the difference here is I'm using pod identity here. And once again, I'm able to do this because I've added some labels that tells the pod identity solution, go ahead and assign an identity to this pod using this label. And let's deploy this. All right. Okay, so it's creating. Now, in order to make sure that the content is actually created, is mounted to the container, let's see if we can get the value out. So this is the value coming from Azure Key Vault. All right, so that was a lot of content. And I'm going to just do a quick recap, right? So what do we show, right? So first, I showed the KMS plugin and why you need it. It basically allows you to create keys and HSM protected keys from a Key Vault for your STD encryption. What this does is it still allows you to manage your secrets, keys, and certs stored in STD, and you restrict the access of those objects in STD with RBAC, service account, and namespaces, things that you guys are already familiar with. But what the difference here is it allows you to bring your own keys. And as I demonstrated earlier, this is available on AKS Engine. If you are interested in hosting your own Kubernetes cluster on Azure. And I just want to mention that this is probably not applicable if you're using a managed Kubernetes service, because chances are that they should really manage this for you, right? So you shouldn't have to worry about this. So for example, AKS would just manage all this for you, so you don't have to worry about it. Now again, for companies that want to store their secrets and keys and certs outside of Kubernetes, there is still a way to do that. And with the Key Vault Flexvolume and pod identity solution, you can basically mount all the secret data into your application via the Key Vault Flexvolume solution. The difference here, however, is the management of the secret data is off of a key management system outside of Kubernetes. And you restrict the access of these objects via the key management system, but you can actually restrict the access to your specific pod with the pod identity solution. And once again, the benefit of this is the separation of concerns, right? To make sure the people, the organization that are managing these secret data are probably not the same people that are using these secret data. And last but not least, to make sure that you can actually have a more granular access control at the pod level as opposed to at the namespace level. So yeah, so these are some links or resources that you can follow up if you want to check out a lot of these solutions that I presented today. And once again, if you have any issues or feedback, we'll definitely love to talk to you. So thank you for your time.